There are multiple rods made of two material. One is X and another is Y. So this material is X and this material is Y. Now, in this rod, temperature of this E is 10 degrees Celsius and temperature of A is given 60 degrees Celsius. What they are asking for, temperature of junction B, then temperature of junction C, and then temperature of junction D. So they are asking temperature of junction B, C and D. Let's say temperature of junction B is TB, temperature of junction C is TC, and similarly junction D is TD. Now simply we have to use Kirchhoff rule. So if you see the data, this one is 60 degrees Celsius, this one is 10 degrees Celsius, and this temperature is TC, this one is what, TD, and this temperature is TB. So if I apply Kirchhoff rule over here, incoming current should be equal to outgoing. So current distribution will be like this, see, and it will go like this. So if we see junction B, there is incoming current. Let's say that incoming current is I1 and that I1 is from A to B. And there are outgoing current in X and Y. So this current is I2 and this one is I3. So what I am saying, let's say this is I1, this one is I2 and this one is I3. And why I am saying it's a current? I am talking about heat current. So I1 should be equal to I2 plus I3. And if I solve this, I1 should be equal to I2 plus I3. How I'll solve this one? I will write Ky into A into T A minus TB divided by L. That should be equal to Kx into A, that is Tb minus Tc divided by L, plus Ky into A, that is Tb minus Td divided by L. And we know Kx divided by Ky, it's already given to us, that is equal to 2. If I use data, Kx divided by Ky, that is equal to 2. So if I solve using that data, so finally what I'll get, 4Tb minus 2Tc minus Td, that should be equal to 60, equation number 1. Now if I apply same rule for junction C, incoming current you can see I2, let's say this one is I4 and this one is I5 and this current is I6. So what I can write now again, for junction C, I2 should be equal to I4 plus I5. And if I substitute this value of this one, so I'll get Kx into A into Tb minus Tc divided by L is equal to Kx into A, that is Tc minus Td divided by L. I'm talking about this one, I'm talking about this, and if I talk about this one, then again that is also Kx thing. So I will write that one, Kx into A, that should be equal to Tc minus Te divided by L, and I am talking about this junction, this terminal. And if I solve this whole thing, so what I'll get, minus Tb plus 3Tc minus Td, that should be equal to 10, that is equation number 2. Now look at junction D. This is the junction D, this one. At junction D, you can see this one end is incoming, this current is incoming, and this current is outgoing. So what is incoming current? I3, and from this one it's I4, and from this one it's I6. So what I can write, I3 plus I4, that should be equal to I6, and I substitute value of this one. So what I'll get finally, if I substitute value of this one, so I'll get Ky A Tb minus Td divided by L plus Kx into A Tc minus Td divided by L. I'm talking about this junction, this one, then plus not plus, that should be equal to, that is ky into a, that is td minus te divided by l, and I am talking about this junction, this one. Right now I am talking about this. So this is equation for this one. This second equation is for I4 and first equation is for I3, like this. So if I solve this again, so what I will get finally, if I solve this equation, last one, so what I'll get, TB, TB plus 2TC minus 4TD, that should be equal to minus 10. Now I got three equation number 1, 2 and 3. This is equation number 3, this is equation number 2, this is equation number 1. And if I solve this all three equation, I will get TB, that should be equal to 30 degrees Celsius, and TC and TD both are equal, that is equal to 20 degrees Celsius.